Write this on top, please. Geometric probability. And really, I'm going to give you an example problem. I guess you could call this probability using shapes. Probability using shapes. Here is me, for instance, example problem here. Find the probability that an object that lands in the larger region will also land in the inner region. Find the prob that an object that lands in the big shape will also land in the small shape. But you have no idea what that means, do you? Mostly because you don't have what? The shapes. So what they're asking you is this. Let's say you're playing darts. And unlike the conventional dartboard, your dartboard is a rectangle. And let's say that rectangle's dimensions are 6 and 8. Well, if you got a rectangular dartboard, guess what? Your bullseye is also a rectangle. Bullseye. And that little bullseye is a 3 by 4 rectangle. They're asking you, what is the probability if your dart lands inside the big square, what's the probability that it's going to land inside the little red square? And basically, it is simply this. It is the, remember, probability is in fraction form. It is basically the area of the small over the area of the big. Area of the small over the area of the big. And in this case, it would be area of the small rectangle, 3 times 4, over the area of the big triangle, 6 times 8. We could do that math, I suppose. 12 over 48. Your probability is 1/4. 1 out of 4 darts should land in that middle area there. How did mine do? Apparently I should have a lot more darts out here, right? Now you say this must get a little more difficult, does it not? This must get a little more difficult. Well, let's actually do a circular board. Let's say you do have a circle and its radius, the radius of the big circle is 10. And the radius of the smaller bullseye circle inside of it, wow, why does that over there? Radius of that smaller one is 6. Okay. Now don't think that you can just put 6 over 10 because that's not going to work. You have to do it like we said. Area of small over area of big. Now the nice thing about this is it's best and easier if when you do this, you just leave pi as pi. Leave pi as pi, and you'll see why in a second here. You know that the area of a circle is pi times radius, correct? Yes, Mr. Hunt, that is absolutely correct. So what we have is on top, pi, what? Times 6 times 6 over pi times 10 times 10. Why do you want to leave the pi's there? Why don't I want to multiply by 3.14, Elijah? Right, because identical factors on top cross off with identical factors on bottom. you can cross off the pi, because they will, it's times pi divided by pi, they go away. You could also, rather than multiplying and get 36, rather than multiplying and get 36 over 100, you could you can cancel before you multiply. In other words, 2 goes into 6 3 times, 2 goes into 10 5 times, 2 goes into 6 3 times, 2 goes into 10 5 times, and you end up with 3 times 3, 9 over 25, which is what you get if you divide both of these by 4. 9/25. If you throw 25 arrows, the probability is that 9 of them would land in that big circle. Yes, no? One more. I'll let you figure this one out. What if you have a rectangle whose dimensions are, let's say it's a square, 10 by 10 square, just to be consistent. And inside that 10 by 10 square, you have a triangle. And the triangle is a what? 6 by 8 triangle. What's the probability of landing in a little triangle? You should be about done. Or very close to it. It's the area of the triangle. Or, there we go. Rectangle. Square. And the answer that we come up with is, well, the area of the triangle, if you do 1/2 base times height, half of 48 is 24. The rectangle is 10 times 10, which is 100. If you reduce those, you end up with, Josh Shelton?
6 over 25.
6/25. Probability.